Sometimes you will have equations in quadratic form, but are more complex in nature. For example, if you look at this one, you're going to have a quadratic, and you could tell it's a quadratic because of the degree of the variable. You can see by the degree this might have up to 2 possible answers. But the variable itself is not just a simple x, or any letter for that matter. It's got this extra information, or this family of information in here that's all being squared. So to simplify this, there's a suggestion that can be made to let u equal the variable part of the second term. Before I do this example, let me show you how long this would take if we did this longhand, which is the way some of you might choose to do this question. So before I do it that way, let's look at it using FOIL, or the long method. Okay, so method 1 would choose to do it the long FOIL way. And this is okay. It's just going to take us a while to get to the answer. So for example, this would be x minus 2 times x minus 2 minus 3 times x minus 2 plus 2 equals 0. So let me distribute everything out. X squared minus 2x minus 2x plus 4 minus 3x. Don't forget that minus sign also distributes to the negative 2 to become plus 6 plus 2 equals 0. And when we combine like terms, we have x squared minus 4x minus 3x, that's minus 7x. 4 plus 6 is 10, plus 2 is 12. You can see that this side will FOIL. Factoring this, I need two numbers that multiply to make 12, but add up to negative 7. Those two numbers will be negative 4 and negative 3. Setting both of these equal to 0, you're going to have x minus 4 is 0, or in other words, x is 4, or x minus 3 is 0, in other words, x is 3. Of course, we would check those answers. I'm going to save the time right now, but you're going to see we have two answers, one at 3 and one at 4. So FOILing all of this out is one way to do this question. I'm going to show you another way that might save you some time. Okay? So in the instructions, it's telling us to do is set u. It could be any letter. I pick u, and we're going to substitute u in for what the variable is of the second term. So if we look at the second term, this is the second term right here. So everything that's being squared and also what's in the second term, we're going to set this equal to u. So we're going to say let u equal x minus 2. Okay? So we're going to rewrite all of this by substituting that in. So if x minus 2 is u, we call this u squared minus 3. Since x minus 2 is u, we call it u plus 2 is 0. And you can see at this point they look identical, but everything in the red box, I've just simplified and made it u instead of everything that's inside of the red box up here. So then this becomes a factor. So when we factor, u times u is u squared, 2 times 1 is 2, and they both need to be negative in order to add up to a negative 3u. So since these are multiplied and the product is 0, we set both of them equal to 0. U minus 1 is 0, or u minus 2 is 0. But remember, we substituted in the very beginning, we said u is x minus 2. So when we solve for u, I don't want the answer of u, I want it in terms of x. So we have to substitute now x minus 2 back in for u. So instead of saying u, we're going to say x minus 2. Instead of saying u, let's call it x minus 2. So when we substitute those back in, we'll find If we add 2 to both sides, x is 3. And if we add 2 to both sides, x is 4. And those are the same two answers that I got on the previous page when we did the exact same way, but this way we did it a little bit longer using the FOIL method. So we did get the same answers. Of course, we always check our answers. So we're going to put those x's back up into the equation. So let's try x is 3 first. So 3 minus 2 squared minus 3 times 3 minus 2 plus 2, is that in fact equal to 0? 1 squared minus 3 times 1 plus 2. 1 minus 3 plus 2, checks. Let's now check x is 4. So we have 4 minus 2 squared minus 3 times 4 minus 2 plus 2 is 0. 2 squared minus 3 times 2 plus 2. 4 minus 6 plus 2. Check. So both of these are answers. Leads me to the answer that x is both 3 and 4 in my solution set. So we're going to work the last remaining problems using the U substitution method, but do note there might be more than one way to do these. Okay, let's look at this question. So in the original instructions, it does tell us to substitute the expression for U into the second term. So this guy right here, we're going to set that equal to U. So we're going to let square root of x equal to U. And let's make sure that it actually does FOIL out to make the first term. Okay? So if I square x, will that actually equal then U squared? Yes, the square root of x squared is in fact x. And that's what we're going to use for this term. So when we rewrite this, x, we can simply use U squared. Square root of x, we can use U. And this becomes a simpler linear equation to solve. This is factorable. Minus 2 minus 3 adds up to negative 5. Negative 2 times negative 3 multiplies to make 6. So either U minus 2 is 0 or U minus 3 is 0, which makes U equal to 2 or 3. But of course we always have to substitute x back in. Instead of saying U, let's call it square root of x. Then, solving for x, we're going to square both sides. So that gives me x equals 4 and x equals 9. Now, of course, we always check both of those solutions to make sure that they work. So over here, let's check when x is 4. Is in fact 4 minus 5 square root of 4 plus 6 equal to 0? Well, let's see. 4 minus 5 times 2 plus 6. 4 minus 10 plus 6. Yes, so this answer does check out. Let's also check x is 9. When x is 9, we have 9 minus 5 square root of 9 plus 6. 9 minus 5 times 3 plus 6. 9 minus 15 plus 6. Yes, so both answers do check out. So my solutions for x are 4 and 9. Two possible solutions, since the original equation was actually a quadratic of degree 2. Let's try another one. Again, remember from the original instructions, it says let the middle term be equal to u. So we're going to let u equal to x to the 1/4 power. If we let the middle term equal to that, we have to make sure that u squared is equal to the first term. U squared is going to be all of this squared. And remember, when you have a power raised to a power, we multiply. So this is x to the 2/4, which is x to the 1/2. And you'll see that that does in fact equal the first term. So we can use the substitution method since both u and u squared equal the middle and the first term. So we're going to rewrite this as u squared for this term times 2 times u, which will be the second term, plus 1. Then we can factor. So we're going to put -1 and -1 in there. So you could see u minus 1 is 0, or u minus 1 is 0, which results in the same answer of u equals 1. They both result in the same answer. Of course, we never state the answer of u equals something. We must say x equals a number. So we substitute back in u is x to the 1/4 power. How do we get rid of that power? Well, we raise both sides to the 4th, because 1/4 times 4 is 1. So that means x equals 1 to the 4th, which is 1. So we check to see whether that is the one and only one solution by seeing if x is 1. So we plug it in. We say 1 to the 1/2 minus 2 times 1 to the 1/4 plus 1 is 0. 1 minus 2 plus 1, it does check. So my answer is x is one and only one solution at the number 1. On to the last page. In the last page, we've got 3 more examples of how to solve polynomials, meaning the degree can be any. Remember, if the degree was 1, this is linear. This is linear. If the degree was 2, we have a quadratic. Anything above that, we simply just call it a polynomial, meaning the degree can be any power at all. When the degree is something higher, like to the 3rd power, or even higher to the 4th or 5th or 6th, we might have more than just 2 answers. This one might have up to 3 possible solutions. So we want to make sure that we check and try to find all of them. First thing I want to do is collect all the terms on one side of the equation, so that way the right-hand side is equal to 0. So the first thing I'm going to do is subtract this x squared and move it over here to the left-hand side. So this becomes x to the 3rd minus x squared minus 2x equals 0. Getting in the habit of writing these in descending order of power is a good habit to make. Then we factor. Factoring this, I have a greatest common factor of x, so I pull that out. You can see that what's left over is still factorable further. X minus 2 and x plus 1 is what would factor this trinomial. This is a zero product property. I have 2 multiplication signs in there, which indicates any of these 3 parts could be 0. So either x is 0, x minus 2 is 0, or x plus 1 is 0, which indicates x could be 0, 2, or -1. Of course, we always want to check all three answers. So let's check x is 0 first. Is in fact 0 to the third minus 2 times 0 equal to 0 squared? Yes, it is. Let's check x is 2. 2 to the third minus 2 times 2 equal to 2 squared. This is 8 minus 4 equals 4. Yes, it is. Let's check the last one. Negative 1, make sure you write it in parentheses. This is negative 1 plus 2 equals 1. Yes. So my answers are x equals 3 possible solutions, negative 1, 0, and 2. The best way to write your answers is in ascending order from smallest to biggest. Next one, again, collect all terms on one side, which they already are, then factor. I'm looking for a greatest common factor, but none of these have a coefficient other than 1, nor do they all have an x, so there is no greatest common factor. So I'm going to try to group. Grouping by factoring means I pull out from the first two terms a greatest common factor. The second two terms, I pull out its greatest common factor as well. Now remember, with grouping, the goal is to have both sets of parentheses to be equal to each other. Once these are the same, that is the common factor to both of these terms that I can pull out in front. Everything that's left over goes in the second set. Now I'm not done factoring. This can actually get broken down even further. X squared minus 4 is the difference of squares. So it could get factored into x plus 2 and x minus 2. Don't forget about that x minus 3 out in front. Now the zero product property says I've got all three parts multiplied together to be 0. So I'm going to set each of these three parts equal to 0. So I could have x is 3, x is negative 2, or x is 2. So I have three possible solutions, of which I need to check all three possible solutions over here. So let's try x is 3. 3 to the third minus 3 squared minus 4 times 3 plus 12 equals 0. This is 27 minus 27 minus 12 plus 12 equals 0. Yes. Let's try x is negative 2. Negative 2 to the third minus 3 times negative 2 squared minus 4 times negative 2 plus 12. This is negative 8 minus 12 plus 8 plus 12 equals 0. Yes. And the last one, let's check if x is 2. 2 to the third minus 3 times 2 squared minus 4 times 2 plus 12 is 0. 8 minus 12 minus 8 plus 12. It also checks out. So I have three possible answers, one at negative 2, 2, and 3. Let's try one more. Last question. Let's get everything to one side, so I'm going to move this term over to this side by subtracting it. So I have 4x to the third minus 3x squared equals 0. Let's factor. Pull the x squared out, which is my greatest common factor. Now at this point, I already have it in fully factored form, and it is the product of two factors that equals 0, so I set both parts equal to 0. So we have x squared is 0, and 4x minus 3 is 0. So this indicates, taking the square root of both sides, x is 0, or x is 3/4. So we're going to check both answers just to be sure. If x is indeed 0, that means 4 times 0 to the third equals 3 times 0 squared. 0 equals 0. That checks. Now x is 3/4. 4 times 3/4 to the third equals 3 times 3/4 squared. Putting this into my calculator, the left side, we're going to have 4 times 3/4 to the third power. You're going to end up with 1 and 11/16. That is a mixed number. If you'd like to turn that into an improper fraction, we can simply do that on our calculator, which would be 27/16. On the right-hand side, we have 3 times 3/4 squared, which is 1 and 11/16. As an improper fraction, that is 27/16. So they do both check out. So my answers, my two answers for this, x is 0 or 3/4 as my two solutions.